consider the three vectors shown in the figure. They have magnitudes a equals 30.5, b equals 5.5, and c equals 32, and the labeled angles are theta a equals 40, theta b equals 20, and theta c equals 15. In what quadrant is the vector a plus b plus c? To find this, we have to get the x and y components of all vectors, and for a, the x component is given by cosine of 40 times 30.5, and for y, it's sine of 40 times 30.5. For bx, we could figure out that in this case the y would be sine and the x would be cosine as well. But if we don't want to have to put the signs in by hand, we can rewrite theta b, which is 20 degrees, as what we would get if we measured from the positive x-axis, which would be 160 degrees. So the x component is 5.5 times cosine 160, and the y component is 5.5 times sine 160. For theta c, the x and y would swap if we just used 15 degrees, but again, we're going to measure from the positive x-axis, and that would give us 270 minus 15 for that angle, and the x component is cosine, and the y component is sine. If we add up all the x components, we get 9.9 units. Add up all the y components, we get negative 9.4. We find the arc tangent of this, and since this program uses radians, we have to multiply by 180 over pi to get degrees. We get negative 43.54. That's in the fourth quadrant. What is the magnitude of the vector a plus b plus c? We already know the x and y pieces, so we just use the Pythagorean theorem to find 13.68. What is the angle between the positive x-axis and the vector measured clockwise in degrees? If we measure clockwise, that would mean we'd end up with 43.57 degrees in the clockwise direction. In what quadrant is the vector negative a plus 2b plus c? Well, we have our components, so we just take negative a, 2 times b, plus c, and add them together. We get negative 41.98 for x and negative 46.75 for y. We get an angle of 48 degrees from the arc tangent, but notice both x and y are negative. This is really in the third quadrant. If we use a more sophisticated arc tangent function, it will figure that out for us and tell us that the angle is negative 131.9 degrees, which is also what we would get if we added 180 to this. In both cases, we'll get 228.1. The magnitude of this vector, again, Pythagorean theorem, gives us 62.836. And the angle between the negative axis and this vector measured counterclockwise in degrees. Here we have to add 180, and we get 48.8.